their gay face on.
Alright, so the objective today is to learn about Newton's laws. Yesterday we talked about forces in motion. So now we're going to look at the laws of Isaac Newton. Your essential question should be the question on page 155 of your notebook, which is how do Newton's laws of motion explain the way things act in our physical world? So yesterday, one of the questions that I asked you is when we had this picture right here, these two pictures down here in the notes, we came up with the fact that those are what type of forces? Unbalanced. Both of them?
Yes.
They're both unbalanced forces, right?
Yes.
They're not equal, they don't cancel each other out. Now, we said both of them will be moving to what direction?
To the right.
To the right. Okay? The top one is moving to the right with a net force of 5 newtons. The bottom one is moving to the right with the net force of 15 newtons, correct?
Yes.
Alright. You got it. Which one's going to move faster?
The bottom one.
Are you Miguel?
Miguel.
Are you Miguel?
And Miguel said the bottom one. And why the bottom one? Because it has more force in newtons. Which I said yesterday was going to lead to what we're going to talk about today. Okay? The reason that occurs is because of one of the laws of Newton, which is the second one. So, what we're looking at, or what the laws tell us, is basically, it describes to us why things act the way they do. Okay? So we're going to look at the first law of motion. The first law of motion says that an object at rest will stay at rest, an object in motion will remain in motion unless a force acts on it. Another way to say this, it's the law of inertia. That's important. It's also called the law of inertia. And the reason for it is because inertia is the property of matter that makes that object not want to change its motion. So if an object is moving, it wants to keep moving because of its inertia. An object that's still wants to stay still because of inertia. Okay? And the bigger the object, or the more mass the object has, the more inertia it has. So, when we say this, or when we look at this law of inertia, what we're looking at is, since the object has a certain mass, if it is still, it doesn't want to start moving. Okay? If it is moving, it doesn't want to stop moving. So if you look at that picture, you have a little card above a cup with a clothespin. If you hit that card hard enough, that clothespin falls straight down. It doesn't move with the little card. Because what type of motion does that clothespin have before the card is hit?
No.
Is it moving any?
No.
No, so it's not moving, right? So it means that the inertia in that clothespin doesn't want it to move. That clothespin doesn't want to move. So, since you basically flip the card away, it doesn't move, but why does it fall straight down?
Because the inertia is bringing it.
Gravity. Because gravity's pulling it down. Inertia is what it doesn't want to start moving. That's why it doesn't go forward. It doesn't go forward because inertia doesn't want it to go forward. Now, the reason it falls down is because gravity brings it down. Okay? So, an example of this would be when you're riding in a car, and that car is going 30 miles an hour, 40 miles an hour, 60, whatever. And for some reason that car has to hit those brakes very, very quickly. What does your body do?
Go forward.
It goes forward.
It tries to stay in motion.
Because the car is going 30 miles an hour. Your body is moving 30 miles an hour. You don't think it is because you think you're staying still. You're not staying still. Are you back there? No, you're with the car, right? So if the car moves 30 miles an hour, you're moving 30 miles an hour. So that means that when the car puts its brakes on,
You
nothing's
put the
braking
brakes on.
you. So your body keeps moving forward. Hopefully, what brakes you?
The seatbelt.
The seatbelt.
If you have one
You
on.
don't.
Or the
If
window.
you have one.
Or the window.
If you don't, you probably, if you're going 30 miles an hour, it's probably not fast enough for you to fly out the window, but you're hitting that dashboard. Now, if you're going 60, and you're gonna fly out.
Like in
Or
like.
or you probably
You're
get
gonna
sprayed
hit,
or
you're going to hit,
We're not talking about crash, we're talking
if
Yeah,
you're
but that's
going
just a
60
car
miles an hour,
crash.
quiet down. If you're going 60 miles an hour and you don't have your seatbelt on, you are going to hit that window. You might not fly out,
Ouch.
but you're hitting that window and you're gonna cause some damage.
to the
Okay?
Give me the next window in front of
In
you.
your head.
Shut
You're
up.
hurt the window.
You're gonna cause some damage.
That's gonna hurt.
That's why you're supposed to wear that seatbelt, because nothing is there to break you. So if that car's going 60 miles an hour, your body's going 60 miles an hour. If they're a speeder like me and they're going 70, 75, 80, your body's going 75, 80. Okay? So,
That's not
you
that
need
much.
to make sure you wear that seatbelt because of this law. Because of the law of inertia says that if an object is moving at a specific speed, it's going to want to keep moving. So, here's my question to you. According to this law, if I take this chair and I push it, it should continue to go and go and go forever and ever and ever, but it doesn't.
because you have enough.
Why? Why?
friction.
What is friction?
It's a force acting on
And what does it want to do?
it. Stop it.
Stop. Okay? So, where could I see this first law of motion, me pushing that, and it going on forever and ever and ever?
Space.
This was, where?
Space.
Why space?
Because there's nothing stopping it.
There's no force.
There's nothing holding it back, or like there's nothing. How you gonna say it? Like
Screw.
Give him some time.
It is right.
Okay, I know there's
Like-
nothing
like-
stopping it, but why
like,
is there nothing
there's
stopping
no gravity, so it doesn't push it down to stop.
it? Very good. There's no gravity, there's no other force, right? So there's no gravity. Now, what other force down here other than gravity would stop that? You said friction, air resistance, right? So out in space, do we have any of those things?
No.
No. So in space, could I, if I was able to, push that chair? Is that chair going to move forever and ever and ever?
Yes.
Yeah.
Yes.
Where's it gonna go?
And just
Okay.
like-
Now,
Where's it gonna go?
if it goes in a straight line forever and ever and ever, eventually,
It'll reach.
it would probably get close to a planet, which has gravity, close to a star, which has gravity, asteroid, anything else. So if it gets close to anything that has gravity, it's going to be pulled in. But until that point, it's going to go in a straight line at the same exact speed forever and ever and ever until it reaches another force. Yes.
Isn't that what they did with one of the, well, I think it was a camera or whatever they were doing in space, and it caught the Saturn's gravity and it shot off of it?
Yes. So, have you ever heard that they've sent like cameras out there to take pictures and stuff, and they just deploy it for it to go just straight? Well, you know, some of them we've lost because of gravitational pull and things like that. Some we have, and it's just kind of they have to calculate on, because you can calculate how everything's moving, and calculate the time it takes to get there and years and things like that. Okay. Any other questions?
Isn't it like also called like a tangential force, things like that? It's like a force that keeps going. Nothing there, right? Because I was still into physics, and they talking about that. Like there was a tangential force that keeps, like if you say you spin a yard, that there's a force that.
You're thinking of centrifugal force.
Something like that.
Yeah.
Something like
No,
that.
we're not thinking.
Oh,
He said
This
something
is
like
just in a straight line.
oh, that's what I thought.
Now,
It was
if I
tangential force.
took if I took a little ball with the string and I did this, okay?
Yeah.
What keeps it in a circle is the force pulling on it. Like I'm pulling on that string, right? But if I let go, that wherever that ball is at that moment in time, it won't keep going in a circle. It's gonna go straight. And that's because of this. That's because of this.
And that's
Yes.
like
So is that like with that card and the paper, whatever that is? I can't remember. The clip.
Yes.
Is that what they do with that tablecloth and the stuff on the table where they
Yes.
pull it off?
Very good. Have you ever seen those people that they have a set table, they take the tablecloth and pull it up, and the table's still set? It's same. This is the principle that helps them do
So
that.
it's real?
So
Yes, it's real.
yeah. If you
Says
do
a lot
it
of people
fast
that.
enough, it will stay.
Can
Okay.
a butterfly sing?
All right. So first law of motion, law of inertia, and inertia basically is the tendency of an object not wanting to change its motion, and it's based on mass. So the more mass you have, the more inertia you have. that makes sense. If y'all did like football, I don't like football, but
I
you
do.
like football. Alright, so what do you call those guys, the really big guys that basically trample
The
on
man.
Huh?
The land. The lineman.
linemen? Okay.
Or like,
So linemen are, those are the really big guys, right?
yeah, the 300
Alright,
pounders.
so that lineman is standing here, and you start trying to push him. Any of us. We're normal.
Well,
Are
what?
we gonna make him budge?
We
Yeah,
can. Yeah, we can.
Wait in order to
No.
do
Hit the
that.
feet.
Hey,
Hit him on the leg.
listen,
I'm not going
you're just pushing him. If you just come over here and you're trying to push him, are you gonna make him move?
No.
No,
We may cause
because
some
they have a
noise.
lot of mass, right?
Yes.
Now, you try coming over here and push me, are you gonna make me move?
Yeah.
Yes. I have less mass, so therefore I have less inertia. It's easier for me to start moving, right? Now, you're standing there, and that lineman is running top speed towards you.
Oh God.
I'll get out of
You
the
get
way.
ran over.
I
I
Are
trick
you
it.
going to be able to stop him very easily?
No.
No.
Triple.
Now, if I'm running
Triple.
towards you, is it probably easier to stop me?
Yeah.
Yeah.
Yes. So, mass is related to inertia. The more mass, the more inertia. So, the bigger the mass, the harder it is to get it to start moving, but also the harder it is to get it to stop moving because of inertia. The less mass, so the lower the mass, the easier it is to get it to start moving, and the easier it is to get it to stop moving. And the reason for it is because it has less inertia. Okay? So, any questions over inertia of the first law?
That's why football, that two part huge.
Yes.
They
Alright,
like
so
meat
now we're going
every day.
into the second law, which actually relates to our pictures that we talked about yesterday. So the second law says that an object acted on by an unbalanced force will accelerate in the direction of the unbalanced force. So when I take this chair and I put a force on it, it accelerated, right? It started moving. And it did that because my force was stronger than the chair's force, because the chair's pushing back on me. Remember, forces are always in pairs. Alright? And that's why it started moving, and that's why it accelerated. So, the second law of motion really is considered the acceleration law. Anytime you see anything about acceleration, it's basically talking about the second law. Anytime it's talking about how an unbalanced force makes something move, it's the second law of motion. So when we think of the second law of motion, we actually have a formula for it. Force equals mass times acceleration, or acceleration equals force divided by mass. It's all the same. Basically, the second law of motion relates force, mass, and acceleration. So sometimes you will see it written like that. Sometimes you will see it written like that. Force equals mass times acceleration. On the STAR test, they use the second formula. But is it the same formula?
Yeah.
Yes, it's just moving the variables around, right? So, just make sure that you realize that the second law is the relationship of force, mass, and acceleration. Alright, so if my force is bigger, what happens to my acceleration? Increases, right? So, if force goes up, what happens to acceleration? It goes up. Alright? If force goes down, what happens to acceleration? It
Less.
decreases. Correct? Alright. The more mass I have, what has to happen to my force in order for it to get it to start moving?
It has to be higher.
It has to be higher. Okay? This is a certain mass. I can do this very easily, right? But if I try to do it with this one, and use the same force, is this going to move?
That is easy.
No, not as easily, right? I need to put more force in there. So obviously, if mass is high, your force has to be higher. I mean, that makes sense. If I want it to go faster, my force has to be higher. So just make sure that you realize that the second law of motion is relating those three different things. Now, if you look at this, here you have a car, a guy trying to push a car. If you've ever had to push a car, it's hard.
Yes, it is.
And make sure it's on neutral, because if
Neutral.
not, it ain't moving. Alright?
Yeah, people follow.
So, if you look, when you
Train.
start trying to push a car with 15 newtons of force and it's 1,000 kilograms, you're just barely going to be making that car move at 0.05 meters per second squared. So in this case, since we're talking about units, what is the unit of force?
Newtons.
Yeah.
Newtons. Okay? Unit of mass that we're going to use?
Kilograms.
Kilograms. And unit of acceleration will be meters per second squared. In acceleration, it is squared. Okay? So make sure you know your units for this formula. So any questions over this one?
So that's what it.
Can you repeat that? Is that an F and then another F?
Yes, if force increases and acceleration
Oh, that's
increases,
an arrow.
if force decreases, acceleration decreases. Yes,
Is the second one with the meters, is that the same formula, but with units?
right here. I'm just showing you the units that go with each one.
So I won't mess up this time.
Yes, you don't mess up. Yeah, I'm just showing you the units that go with each one. Alright, so any other questions over this one? Alright, then we go on to the third law of motion. The third law of motion is basically the action-reaction law, which basically says that for every action, there's an opposite equal reaction. If I come over and I slap you in the face, you're going to want to slap me back. For every action, there's an opposite equal reaction. Okay? You're going to want to. Now, hopefully you don't, and hopefully I don't do it the first time. But you're going to want to. Anybody hits you, you're going to want him back. I mean, just natural.
Not most. Some
The
people.
natural emotion is to want to do it.
But
now,
isn't
whether
there-
you do it or not is a different story.
Isn't
Okay,
there?
give me a second. So basically, with forces, that's the way it works. For every action force, there's an opposite reaction force. If I come over and I start leaning on this table, my force is leaning on the table. The reason I know that this is acting a force back on me is because this table ain't moving. Am I moving? Is the table moving? So I'm pushing on this table. The table's pushing back on me with an equal force. That's why neither the table's moving, neither I'm moving. Okay?
Equal
So
force.
that is what the third law of motion says. An opposite equal reaction. So if you look at this picture, you have a balloon. It's full of air. If I let that air goes down, right? When that air goes down, the floor pushes back up, right? It's pushing back on something. So you have this action rushing down, and the balloon goes up because it's being pushed up. That's an opposite equal reaction. So that's how we can get the spaceships up into space. Because when the boosters go, they're pushing down air or gas. The explosion pushes down gas, and it pushes the rocket up. Okay? So that is what the third law of motion says. It's an action-reaction. Okay, Jesus, you had a question?
I was talking about the slapping thing. That there's a religion where if they hit you, you don't hit them back. They just take it.
Yeah, well, that's just an example. I'm not going to hit you.
Hope not.
Yes,
Do you have those ball thing?
that's Newton's cradle. Yeah, Newton's cradle basically shows the first law of motion.
No, but do you have one?
No. Yeah, the Newton's cradle is basically to show the first law of motion because when it hits, it just continues to do it over and over again. Okay? It also shows you second law because it's accelerating, and it shows you the third law because it's, action-reaction. So what you need to realize is that anytime anything moves, it doesn't matter. Anything moves. All three laws are happening. All of them. So if I come in and do this, that moved, right? All three laws happen at exactly the same time. The reason that it moved or started to move or continue to move is because there's an unbalanced force and it accelerated, right? That's second law. It continued to move even though I didn't continue to push on it because of the first law. When something moves, it wants to continue to move. okay? And then third law of motion is when I pushed, it pushed me back. Now, was its pushback enough for me to
No.
do that? No, but there's a pushback. So what you need to realize is that with everything, all three laws are demonstrated. Now, if with everything, all three laws are demonstrated, and on a test they want to see if you know them, they're going to give you an example. They're going to say, all right, a ball is taken, it's thrown to the wall, and it bounces back. So the ball bouncing back from, the ball bouncing from the wall back. Example of what law? You know that all three laws are working there, right? But the bounce back
It's equal.
is what?
Opposite.
Third law.
Third law, opposite and equal. So, you're going to have to be very careful when they start giving you examples, because you really have to read what are they talking about. Are they talking about acceleration? Second law. Are they talking about the fact that it's going to continue to move, bless you, or not move? First law. Are they talking about action-reaction? Third law. So you really, really, really have to pay attention to what they're telling you to look at, because everything, every type, every motion is going to have all three laws in it. So you're going to have to be very careful. So let's talk about some key words. First off, what are some key words that you need to pinpoint or pay attention to? What is the easiest one to pay attention to? Inertia. Okay, inertia. It wants to keep moving. So if it continues to move without any motion, so do I have to push on this chair for it to get all the way to here?
No.
No. What keeps it going is that first law. I don't have to continue to push it, right? What keeps it going is the first law. The fact that it wants to keep moving because it's already moving. Okay? Alright, second law. If they talk about accelerating or moving, second law. Okay? And then third law, an opposite reaction force. Okay? Something's happening because this other thing happened. Alright? So any questions over any of those? Alright. On page 154, I want you to make page 154 3 columns.
No,
It's called the Newton's Gallery Walk. So you can title it Newton's.
Do I stop it?
I'm sorry?
Do I stop it?
No.
Okay.
Newton's Gallery Walk. And you need 3 columns. If you want to do it this way, you can. If you want to do it the other way, it doesn't really matter to me. Alright, so right here you're going to put example, law, reasoning. What you're going to do is you're going to do a gallery walk in just a second with your partner. You're going to look at several pictures. The pictures have a writing, so you basically a scenario. You're going to have to copy that scenario. Not copy the picture, copy the words, what it says, okay? Then you and your partner decide what law is being shown in that example. First law, second law, and third law. And then I want a reason. Okay? The reason, why is it the first law? Why is it the second law? Why is it the third law? Okay? So, any questions of what you're going to be doing? Alright, so finish setting up. This was all.